Hello, and welcome to this overview of AbLead, an antibody analysis and engineering suite from Ketchum Biotherapeutics Consulting. In this video, I'm going to show you a demonstration of the assembler module to be able to assemble antibodies from variable domains. I'll select a representative set, say a couple of kappa molecules, a lambda molecule, and from there I will go into the assembler. What the assembler has done behind the scenes is recognize that there's kappa domains, there are lambda domains, and there are heavy domains. And it's placed them into these module groups to be able to build out their leader sequences in constant domains. I could just click build FASTA or build MABs here, and it would build them out back into the main grid or save the FASTA file as straight FBs with no leader sequences and no constant domains. But in this demonstration, I'll show you how to build them out as full-length antibodies. I'll start with the leader sequences. I don't want to show all 601, so I'm going to use filtering to find a good leader sequence for the lambda chain. Now the tool lets you be flexible. I could move the leader sequence to the C-terminus of the variable domain, but of course I wouldn't do that. So I'm going to put it here at the beginning. And then I'll go back to filtering and change this to a leader sequence that's suitable for kappa and for the heavy chain. Now I've got those set. I can collapse the leader panel, go into the kappa. If I click on any of these modules, you can see here that it shows the sequence of interest. You could copy and paste this elsewhere if you wanted to evaluate it. But I can grab this, put it onto the kappa domain. I'll open lambda, put this on the lambda domain, and now I have constant domains on the light chains. And then as I come down and click on the other modules, I could choose to select a CH1 of interest. I could select a hinge of interest. I could select a CH2 and a CH3CS and build it out manually. But I also have in this other category a set of full-length heavy chains that are already built out. A hinge modified G4, a normal G1. In this case, let's use a G1 with the half-life extension extend LS and the LALA PG effector functionless modifications. So I can just grab that as a module and put it on the heavy chain. Now, when these are in place, this is how I'd like it. This is going to build them out with kappas getting the kappa modules, lambda getting the lambda modules, the heavy chain getting the heavy chain modules. I just click build MABs. It sees there's 3 items to process because there were 3 entries that I had selected. It's putting them back into the main grid. It's built the sequences. This removes the human error from copying and pasting in an editor. This does it for you. So I'll return to the tool. It doesn't just leave the tool. You can come in and delete these, change it out, build new sets, however you'd like. But I'll come back to the main grid, and you can see that those assembled molecules have been built. Other than there being no PDB file, and so the surface properties have not been calculated, everything else would be the same between the parent and the child assembled molecule in this case, because all we've changed is the constant domains. And you can see that the tool has automatically built out the lineage. So I could come in here and select these and look at them in an alignment at this point. If I wanted to verify that what was done was correct, you can see the name is a little long, so I can just pull out the alignment a little bit. But the differences aren't in the variable domains. I added leader sequences, and I'll show consensus and fade the consensus, and you can see that the leader sequences that I used were identical to the parent. And we can look at the constant domains and see that the light chain constant domains are identical to the parent, but in the heavy chain, I introduced from a G1 the LALA PG. So there's LALA, there's PG for effector functionless modifications, and there's the LS change for half-life extension. I could also come in and use the mutation grid if I wanted to see this just as individual parent-child mutations. And there's LALA PG, LS for each of the 3 that I had selected. I can export these as a grid to record it in my ELN. I could export these as fast A to be produced. I could keep them in the entry for further evaluation or just as part of the project. So that's an overview of the assembler, and I'll see you in the next video.